We've all been there. You're deep into a complex task with an AI, it finally understands your project, or, it's helping you debug some weird legacy code.
Hmm.
And then, disaster. The network glitches, you close the terminal, or maybe you just step away for the weekend.
And you come back, you greet your helpful digital partner, and it greets you back like you're a complete stranger. All
Yes.
that context, all that effort you spent getting it up to speed, poof, gone. It's probably the single most frustrating thing in tech right now, the AI goldfish effect.
It is truly maddening. I remember spending, I think, 2 hours explaining a database structure to a bot, only for it to forget the primary key name because I had to switch environments. This statelessness, it just means every single interaction starts from zero.
Right. It completely prevents the AI from being a real partner. It's a tool you have to reset over and over again. I mean, if this were a human colleague, you'd be worried. It's like meeting a friend who has to introduce themselves to you every single day.
Exactly.
Yeah.
But today, we're doing a deep dive into a specific technical framework that claims to get rid of this problem entirely. Creating AIs that, and this is the key, never forget. We are looking at Prince's Memory Agent GitHub repository. It's a complete open source framework designed for persistent conversation.
Okay, let's unpack this. What exactly makes this the elephant solution? And why can't we just, solve this with a simple database or a really big prompt?
That's the core question, right? The reason statelessness is such a huge problem is the inefficiency. Standard LLMs, they only see the immediate prompt and maybe a little bit of session history that fits in the context window. Once that window closes, the information is just gone. This framework, it shifts that whole paradigm by providing a structure for what we call semantic memory.
Semantic memory, that's the key technical term here, isn't it? It's not just remembering the last 5 lines of chat. It's remembering who I am, my preferences, even months later. Precisely. It lets the AI function like an elephant by persisting that data across sessions and integrating that context intelligently.
Yeah.
To do this, it really leans on organizational architecture, specifically Google's ADK.
The Agent Development Kit.
Yeah.
Let's clarify its role, because that acronym gets thrown around a lot. What heavy lifting is it doing that say, a standard Python script can't?
The ADK is the organizational layer. It's a platform designed to orchestrate complex operations way beyond simple API calls. It manages the agent's tools and services. So in this case, the ADK is the engine that lets the memory service, the LLM, and the preloading function all talk to each other seamlessly. It makes state management part of the agent's core function, not just some external add-on.
So when you clone this repository, you're not just getting code, you're getting a whole architectural blueprint, a personal assistant starter kit, basically. Let's look inside the files that actually make this work.
Okay, we should start with the brain of the operation, the day3b-agent-memory.ipnb file. It's a Jupyter notebook with all the Python logic.
Yeah.
When you open it, you see 3 key things being defined right away.
And those are?
First, the Elm agent. Think of this as the AI's persona. It holds the Gemini model, it gets the initial system instructions, and that defines its role. Second, it initializes the memory services. That's the in-memory service, which is our persistent vault. And third, it sets up the runner.
The runner. Okay, that sounds important. If the Elm agent is the brain and the in-memory service is the vault, what's the runner's job?
The runner is what executes the conversation loop. It's the process that's constantly listening, sending the prompt to the Elm agent, getting the output, and keeping the flow going. In a normal stateless bot, the runner just stops when the session ends. Here it's configured to talk directly to the memory service at the start and end of every single cycle.
Okay, and of course, setting up any project like this needs dependencies. We see the requirements.txt file, the ingredients list.
In this file, it lists libraries like Google AdGig, Google Gemini, Jupyter. These are not optional. For anyone listening who wants to try this, this is your first, most crucial step.
And we really need to stress this because the source material is very clear. Running pip install egtar requirements.txt is mandatory. If you skip it, you're guaranteed to get module not found errors, and the whole thing will crash before it even starts. So get the environment stable first.
Absolutely. Stability is key. And it's also worth looking at the documentation, the re80me.md and the product report.md. They're not just filler. They have architectural diagrams and text-based demos that show how the system maintains memory. It really helps you understand the why behind the code. Okay, now for the secret sauce. This is where we look at the actual mechanism of persistence. What's fascinating here is just the elegant engineering behind how the agent logs information without you, the user, ever having to interrupt the conversation. We call it the spy mechanism.
And that's the callback function at work. Let's walk through the 4 steps of this workflow, starting with just, well, the conversation.
Step 1 is simple. It's just user interaction. You talk to the agent naturally. You say something like, I'm a coffee enthusiast, and I prefer single-origin beans from Ethiopia.
Then step 2 is where the magic starts. The spy. The after-agent callback. This is running silently in the background, right? Triggered after the agent responds.
Exactly. It's like a silent stenographer. You never see it, but the moment the agent finishes its turn, maybe it says, that sounds delicious. The spy immediately grabs the full transcript segment. It captures your input and the agent's full response.
Okay, but that's a huge architectural choice to capture everything automatically. Wait a second. If the spy grabs every word, every joke, doesn't that create a ton of data bloat? And what about the compute cost? You're filling the vault very fast.
That is an excellent point, and it gets to the necessary trade-offs you have to make.
Right.
While the framework ingests the full transcript, the real intelligence is in step 3, ingestion and filtering.
So tell us about the vault.
The spy pushes that transcript into the in-memory service, the vault. But crucially, the ADK framework handles the indexing and even potential summarization of this data. It's not just dumping text files. It's using vectorization and semantic indexing to figure out what's a valuable persistent fact versus what's just, noise.
So the system is basically tagging important facts, my name, my project goals, and giving them a higher retrieval weight while letting the small talk kind of fade away. It's building a knowledge graph about me.
You got it. It achieves passive integration. You don't have to type save favorite beans. The system just knows that's a preference and indexes it, ready for instant retrieval.
Okay, that solves the storage side. But how does the agent use this when I come back a week later? That's step 4, retrieval.
Retrieval is managed by a tool called preload memory. When a brand new session starts, before the agent even says its first hello, the runner executes this preload memory function.
That sounds really different from standard argide retrieval augmented generation, where I ask a question and then the system goes and looks for an answer.
It's fundamentally different. Standard argide is reactive. This is proactive memory loading. The agent uses your ID to get your file from the vault, and it pulls all the high-priority index context into the Elm agent's context window right at startup, so it wakes up already knowing who you are. It's the difference between a lawyer who searches a file cabinet when you ask a question and a lawyer who has a summary of your entire history highlighted on their desk before you even walk in the door.
That shift from reactive argay to proactive memory, that is a genuine game changer for user experience.
Okay, for those of you listening who are ready to get hands-on, the source material gives a really clear 4-step guide to run a memory test yourself.
Step 1, like we said, is installation and setup. Download the repository, make sure your environment is set up, and run those dependencies. Don't skip it.
Step 2 is the ignition key, authentication. You absolutely need a Google Gemini API key. The framework is designed to look for this key in your environment variables. Without it, the engine just won't start. Right. Once you're running, you go to step 3, the first date. This is where you train the agent. You feed it information you want it to recall later. For example, run the notebook and tell the AI, my favorite superhero is Batman, and I live in Gotham City.
And as a developer, you should actually watch the output logs. You'll see a little confirmation that the system has ingested this fact into the vault through that silent callback.
Now for the moment of truth. Step 4, the recall. You have to simulate persistence. So you stop the code, you close the Jupyter notebook, you simulate a full break, then you restart a fresh session, a clean slate.
And the test question, the proof it worked, is you just ask the AI, who is my favorite superhero?
And the expected result is that the agent answers instantly, it is Batman. It didn't have to guess, it didn't have to ask you again. It used preload memory at startup to recall that fact, proving it has cross-session memory.
So what does this all mean? I mean, beyond just fixing a technical bug, this framework seems to fundamentally change how you'd build a complex AI application.
Absolutely.
Yeah.
This repository isn't just a demo, it's a template for the future of AI interaction because it allows for genuine long-term relationships. We're moving from a purely transactional AI to a relational one.
Let's talk about the high-impact use cases the sources mentioned, because this transition makes some AI concepts that were just too cumbersome before suddenly viable.
Take education. Smart tutors are often frustrating because if a student leaves, the bot forgets their learning profile. With persistent memory, the tutor remembers that last week the student struggled with geometry but was great at algebra, so it can tailor the curriculum right away. That's personalized education at scale.
Or in the healthcare field, medical bots are often restricted because repeating patient history is risky and inefficient. A memory-enabled agent could retain complex history, allergies, past surgeries, chronic conditions, without the patient having to repeat themselves, making the whole process safer and faster.
And for commerce, think about personalized shopping assistants. Instead of just remembering your last purchase, the assistant remembers your sizes, that you hate polyester, the aesthetic you were going for 3 months ago. It can use that stored context to instantly refine its suggestions. It becomes proactive.
This template feels like the missing piece that turns a clever chatbot into a reliable digital partner. Prince didn't just fix a bug, he's provided the architecture for sustained interaction.
Exactly. This is the blueprint for the persistent AI of the future. The building blocks are right there on GitHub. It's up to developers and innovators listening to download it, get that ignition key, and start building a world where our AI partners are finally as reliable as they are intelligent.
The goldfish has finally gained an elephant's memory. Now the real building can begin.